scientific fraud crisis. Fixing it like emptying a bathtub with a spoon. Research fraud is exploding at a pace that outstrips all efforts to stop it. It's like trying to bail out a flooded bathtub with a tiny spoon. This stark reality was highlighted in a recent study that delves deeply into the widespread problem of fraudulent scientific publishing and the complex networks that perpetuate it. But here's where it gets controversial. Despite growing awareness and attempts to fix the issue, fraudulent publications are increasing much faster than they are being corrected or removed. Published on August the 4th in the Proceedings of the National Academy of Sciences, the study exposes how entities like paper mills, brokers, and predatory publishers churn out low-quality or entirely fabricated research. These groups often manipulate the system by selling authorship spots and bypassing rigorous peer review processes, flooding academic literature with suspect work. Anna Abalkina, a respected researcher from Freie Universität Berlin and creator of the Retraction Watch Hijack Journal Checker, praised the study for its comprehensive look at just how rampant research fraud has become. She also highlighted its innovative methods for detecting dubious papers and the networks of editors who enable their publication. The problem of paper mills isn't new. It has been under scrutiny by researchers and investigative journalists for over a decade. These mills have infiltrated numerous publishers, causing widespread retractions even before the highly publicized massive withdrawals from Hindawi journals. The latest research confirms a troubling trend. The output of suspect papers. Luis Amaral, a professor at Northwestern University and co-author of the study, metaphorically described the fight against this wave of fraud as emptying an overflowing bathtub with a spoon. This analogy vividly captures the overwhelming and persistent nature of the problem. To gain a clearer picture of the underlying networks, Amaral's team analyzed metadata from journals like PLOS One and conference proceedings from IEEE, cross-referencing this data with retraction records and pub peer comments. They uncovered troubling clusters of editors who seemed disproportionately inclined to accept papers that were later retracted or flagged, indicating systemic issues within editorial practices. PLOS One, a journal openly accessible to all, has been a notable target for paper mills in the past. The study found that just 45 editors, who handled about 1.3% of all articles, were responsible for overseeing 30.2% of all retracted papers. Shockingly, more than half of these editors had also authored papers that were later retracted themselves. Renee Hock from PLOS explained that once this surge in paper mill activity was detected several years ago, the publisher ramped up efforts to scrutinize articles, authors, and editors rigorously before publication. But she also emphasized that these issues are industry-wide, not just confined to PLOS One. Similarly, IEEE conference proceedings have long been fertile ground for paper mills, and Amaral's team found repeated instances of suspiciously high retraction rates and flagged works concentrated in certain recurring conference series. Despite this, IEEE stated their vigilance through continuous library inspections and corrective actions such as retractions when necessary. Looking beyond individual outlets, the researchers mapped networks of duplicated images, a hallmark of fabricated research, across multiple major publishers like Springer Nature, Spandados, Wiley, and Elsevier. They discovered clusters of papers with repeated images appearing around the same time. A striking 34.1% of these flagged papers had been formally retracted. This network-focused approach to detecting fraud is new and was praised by Abalkina as revealing the extensive reach of paper mills, likening them to an octopus ensnaring increasingly more scholars. The study also zoomed in on specific research areas, such as RNA biology. Here, fraud impacts were stark. Fields compromised by misconduct experienced retraction rates near 4%, compared to just 0.1% in unaffected subfields. Furthermore, the team explored what they call journal hopping, a tactic used by paper mill brokers like the Academic Research and Development Association, ARDA, which guarantees publication in certain journals. When journals in their list were removed from indexing services due to poor standards, new ones were swiftly added to replace them. Despite current detection and correction methods, the numbers tell a grim story. Only about 28.7% of suspected fraudulent papers have been retracted. Extrapolating from current trends, the team estimates that merely 1 in 4 such papers will ever be pulled, and fewer than 10% will land in journals delisted from major databases. This likely underrepresents the real scale, since it depends on detected fraud cases, leaving a massive, hidden iceberg below the surface. So what can be done? Amaral draws a parallel between addressing scientific fraud and tackling the ozone layer crisis. Both require large-scale, coordinated, global action. He urges leading science organizations worldwide, such as the US National Academies, the Chinese Academy of Sciences, and the UK Royal Society, to take decisive leadership. Only by setting and enforcing strict standards across publishers, funding bodies, universities, and labs can meaningful change occur. This isn't a problem any one person or small group can fix. It requires systemic reform and insistence from the biggest players. Yet individuals aren't powerless. Reese Richardson, a postdoctoral researcher and study co-author at Northwestern University, stresses the role scientists can play by pushing policymakers to ease the hyper-competitive atmosphere fueling misconduct. Researchers are competing intensely for scarce resources, which can tempt some to commit fraud. Scientists can also contribute by rigorously reviewing the literature post-publication and staying alert to the suspicious patterns. Moreover, developing automated, high-throughput tools to catch problematic papers is crucial. Meta-scientists, those who study the scientific process itself, can use public signals, like comments on PubPeer noting image duplications or misidentified equipment, as clues to reveal hidden misconduct. Richardson and Amaral have even developed such tools, which, for instance, detect papers that incorrectly identify microscopes used in research, an unusual but telling red flag. Amaral expressed a heartfelt sense of community among those fighting scientific fraud, acknowledging the importance of science's ideals and the shared commitment to preserving them. This study shines a light on a growing crisis in scientific publishing and challenges the research community and its stakeholders to recognize the scale of the problem and respond with urgency and unity. Is the scientific world ready to confront this head-on, or will it continue juggling an overflowing bathtub with a spoon? What do you think? Are stronger, centralized interventions the only way out? Or can individual researchers and grassroots efforts turn the tide? Join the conversation and share your views. The dark side of science. Organized fraud exposed. The alarming rise of organized scientific fraud demands urgent attention. A recent study from Northwestern University reveals a troubling trend. Organized scientific fraud is escalating at an unprecedented pace. This includes everything from falsified research to the buying of authorships and citations. By employing extensive data analysis of scientific literature alongside detailed case studies, the researchers conducted a thorough investigation into the realm of scientific fraud. While discussions about scientific misconduct often spotlight individual wrongdoers, this study highlights the existence of intricate global networks of individuals and organizations that collaborate systematically to erode the integrity of academic publishing. The situation has become so dire, that the rate of fraudulent publications is now surpassing that of legitimate scientific works. The authors of the study assert that these findings should act as a crucial wake-up call for the scientific community, urging immediate action to prevent a loss of public trust in the scientific process. The research, titled "The Entities Enabling Scientific Fraud at Scale Are Large, Resilient, and Growing Rapidly," was published in the Proceedings of the National Academy of Sciences. Science must take greater responsibility for its own integrity, stated Louise A.N. Amaral, the senior author of the study from Northwestern. If we fail to raise awareness about this issue, increasingly unethical behavior will become the norm. Eventually, it will be too late, and the scientific literature will be irreparably tainted. Some may fear that discussing this issue equates to attacking science, but I firmly believe we are defending science from those who would exploit it. We must recognize the gravity of this problem and take proactive steps to address it. Amaral, who specializes in complex social systems, holds the position of Erastus Otis Haven Professor and teaches engineering sciences and applied mathematics at Northwestern's McCormick School of Engineering. The paper's first author, Reese Richardson, is a postdoctoral fellow in Amaral's lab. In-depth analysis. When people think of scientific fraud, they often recall news stories about retracted papers, falsified data, or instances of plagiarism. These narratives usually focus on the actions of a single individual who resorts to unethical shortcuts in a fiercely competitive field. However, Amaral and his team have uncovered a vast underground network that operates in secrecy, far from public scrutiny. These networks function like criminal organizations, collaborating to fabricate the scientific process, Amaral explained. These operations involve millions of dollars. To carry out their study, the researchers examined extensive datasets that included retracted publications, editorial records, and cases of image duplication. Most of the data was sourced from major scientific literature aggregators such as Web of Science, WOS, Elsevier's Scopus, the National Library of Medicine's PubMed Medline, and OpenAlex, which compiles data from various institutional repositories. Richardson and his team also gathered lists of de-indexed journals, scholarly publications that have been removed from databases due to failure to meet quality or ethical standards. Additionally, they included data on retracted articles from Retraction Watch, comments from PubPeer, and metadata such as editor names and submission dates from articles published in specific journals. Purchasing a reputation. Upon analyzing the data, the researchers discovered coordinated efforts involving paper mills, brokers, and infiltrated journals. These paper mills operate like factories, producing large volumes of manuscripts that they sell to academics eager to publish quickly. The quality of these manuscripts is often subpar, containing fabricated data, manipulated or stolen images, plagiarized content, and sometimes even nonsensical or physically impossible claims. An increasing number of scientists are becoming entangled with paper mills, Amaral noted. Not only can they purchase papers, but they can also buy citations, allowing them to present themselves as reputable scientists, despite having conducted minimal research. Richardson added, "Paper mills operate under various models, and we have only begun to scratch the surface of their operations. They essentially sell anything that can help launder a reputation, including authorship slots for hundreds or even thousands of dollars. Individuals might pay more for a first author position, or less for a fourth author position. They can even pay to have their papers automatically accepted in a journal through a fraudulent peer review process. To identify more articles linked to paper mills, Amaral's group initiated a parallel project that automatically scans published material science and engineering papers, specifically looking for authors who misidentified the instruments used in their research. A paper detailing these findings was accepted by the journal PLOS One. Brokers, hijacking, and collusion. Amaral, Richardson and their collaborators identified several key strategies employed by fraudulent networks. 1. Groups of researchers collaborate to publish papers across multiple journals, which are later retracted when discovered. 2. Brokers act as intermediaries, facilitating the mass publication of fraudulent papers in compromised journals. 3. Fraudulent activities are concentrated in specific, vulnerable subfields. 4. Organized entities circumvent quality control measures such as journal de-indexing. Brokers connect all the various players behind the scenes, Amaral explained. You need someone to write the paper, individuals willing to pay for authorship, a journal to publish it, and editors who will accept the paper. In some cases, these organizations bypass established journals entirely, seeking out defunct journals to hijack. When a legitimate journal ceases publication, for instance, unscrupulous actors can take over its name or website, assuming the journal's identity and lending credibility to their fraudulent publications, even though the original publication is no longer active. Richardson cited an example. This occurred with the journal HIV Nursing, which was once affiliated with a professional nursing organization in the UK. After it stopped publishing, its online domain lapsed. An organization purchased the domain name and began publishing thousands of papers on topics unrelated to nursing, all indexed in Scopus. Defending science, to counter this escalating threat to legitimate scientific publishing, Amaral and Richardson stressed the necessity of a multifaceted approach. This strategy should include enhanced scrutiny of editorial processes, improved detection methods for fabricated research, a deeper understanding of the networks facilitating this misconduct, and a radical overhaul of the incentive structures within the scientific community. They also highlight the urgency of addressing these issues before artificial intelligence, AI, further infiltrates scientific literature. If we are unprepared to tackle the fraud that is already present, we will certainly be ill-equipped to handle the implications of generative AI on scientific literature. Richardson warned, "We have no idea what will end up in the literature, what will be accepted as scientific fact, and what will be used to train future AI models, which will then generate more papers." Amaral expressed his dismay, stating, "This study is perhaps the most disheartening project I've ever been involved with. Since childhood, I've been passionate about science. It is distressing to witness others engage in fraud and mislead the public. However, if you believe that science is vital for humanity, you must advocate for its integrity. For further details, refer to the study. The entities enabling scientific fraud at scale are large, resilient, and growing rapidly. Published in the Proceedings of the National Academy of Sciences, 2025. DOI 1073/PNAS 2420092122.